respected principal of the college, respected HOD sir, as well as the all the faculty members of mechanical engineering department and Royal Mechanical Engineering students of the Vidyaniketana College of Engineering, Tirupati. You can see my presentation. As the name itself indicates, the role of mechanical engineers in an aerospace domain. If you see this term, the role of mechanical engineers in an aerospace domain, what our mechanical engineers are going to play in a development of an aerospace product. If you take any domain, not only aerospace, if you take automotive sector, or if you take plastic domain, or if you take any industry, from mechanical domain to the software domain, what are the different components you are seeing? Right now you are using maybe laptop or mobile, you are sitting on the chair or in the chair, or you have kept your laptop on the table, whatever it may be, you take any component, our Royal Mechanical Engineers are going to play huge role. So in this particular presentation, I have taken only with respect to the comparison between the aerospace as well as the automotive sector, how our mechanical engineers are going to play huge role to make any aerospace product, or it may be automotive sector. And whatever you are studying from the first semester to the 8th semester, different type of subject, different type of domains. If you take the in mechanical itself, n number of domains are available, like manufacturing, design, quality, testing, n number of fields, thermal, n number of fields are available in the mechanical domain. With respect to the each domain, you are going to study different subjects. It may be starting from elements of mechanical engineering, or it may be computer, or it may be, we can call it as a drawing. You can see a number of manufacturing subjects, thermal subjects, design subject, quality related subject, product development related subject. So how, as an industry person, we are going to use these subjects to make one product. If you see, to make any product, it starts from the customer and end with the customer. That means here customer is going to play huge role by placing his requirement or his order to the industry, and industry persons are going to develop that particular product, and finally that product we have to hand over to the customer in such a way that should be useful to the customer, then only he is going to accept. So from customer to the customer, whatever in between different steps are there, like placing order, converting that order to the sale order, that sale order to the purchase order, then production order, and different steps, quality, then it may be testing and handing over to the customer. Different types of cycles are there. How we are going to play huge role to deliver that particular product to the customer, and what are the different steps are involved, everything we are going to discuss in this particular 1 hour to 1 hour 15 minutes technical session. I hope this session will be useful for our young mechanical engineers, especially those who are interested in design field, manufacturing field, or it may be testing. That means, I mean to say, it is going to cover all aspects of mechanical domain. So if you see this second slide, sir, is it visible, the second slide? One aircraft as well as the one car.
Yes, sir.
Now, if you see here, two different types of products are there. One product is related to the automotive sector. You can see this Jaguar car, and one more product is related to the this particular F-16 aircraft. Now, customer is going to give order to a particular aerospace domain or aerospace industry in such a way that he needs these kind of 100 aerospace products with certain requirements. For example, when you are going to shop to purchase mobile, ultimately what you are going to see, young engineers, ultimately, or young mechanical students, we can take example, what they are going to see, They are going to see whether that particular mobile is having this much GB or not, around 256 GB or not, or 8 GB RAM is there or not. What about the screen? Screen size is only normal, or it may be bigger size. Like that, you are going to check. So if that particular mobile meets your requirements, then only you are going to purchase. Otherwise, you are not going to purchase. You are going to see other mobile or other shop you are going to visit. Like that, whenever a customer is going to place a order, he is going to have his own requirements. That means he is going to give his conditions in the purchase order. That means when he wants these kind of 100 aerospace products, he is going to specify three important terms. Throughout this session, we are depending on these three important terms. First important term is the at which speed this particular aerospace product has to travel. This is the one important thing. That means it is going to travel with a velocity of 2000 kilometers per hour. His requirement, whatever product we mechanical engineers are going to develop, that product should be capable to travel with a velocity of 2000 kilometers per hour. This is his first requirement. Second requirement, with this speed, how many hours this particular product has to travel? This is one more important requirement. That means if it is traveling with a velocity of 2000 kilometers per hour, only for 1 hour means what is his use? If he wants to make any mission, since this is the fighter aerospace product, he want to put a bomb or he want to put some kind of mission or the opposition party. So ultimately he should have some kind of endurance. That means he should be minimum capable to travel in the air for 5 hours or it may be 6 hours, like that. That means he's going to mention clearly this aerospace product with a speed of 2000 kilometers per hour, it should travel minimum 6 hours continuously. This is his second requirement. Third requirement is always, as we know, mechanical engineers or it may be our research followers or faculty members, always the efficiency of that any aerospace product or it may be automotive product is mainly depending on the weight, or we can call it as a mass of that particular product. This entire weight of the product should not be more than 10,000 kg. So these are the three important requirements from the customer. First requirement, whatever product we are going to hand over to the customer, that should capable to travel 2000 kilometers per hour. Second requirement, with that velocity, it should travel continuously for 6 hours. Third important parameter, whatever product we are handing over to the customer, that product should not be greater than weight, mass of that product should not be greater than 10,000 kg. So these are the requirements. When this kind of order comes to any aerospace industry or it may be automotive sector, maybe you can map with automotive sector parallelly to manufacture these kind of automotive products. Maybe testing and other parameters may be different compared to the aerospace. So if these kind of products are already available in the premises of that particular industry, which is going to supply 100 numbers to the customer, then no issue. Only thing we have to purchase the raw material, do whatever you want that manufacturing process and fabricate the product, hand over to the customer. If not available in the particular industry, like maybe in that particular industry they are having one aerospace product which is capable to travel with 1500 kilometers per hour and which is capable to travel up to 8 hours, and mass of that particular product may be around 8000 kg. So like that they may be having different products, but whatever customer has given right now, that may be not there. So ultimately at that time, this one will become the new project for that industry. How to begin, how to start this project is very important, where our Royal Mechanical Engineers are going to play very important role. Now your role is to develop aerospace product which is capable to travel 2000 kilometers per hour with a velocity continuously for 6 hours, as well as the entire product mass should not be greater than 10,000. Now this one is in your hand, you have to develop and you have to deliver to the customer. Maybe project time may be 5 years or it may be 6 years, because aerospace products always takes more time compared to the automotive sector, because whatever products are developing with respect to the aerospace domain. Ultimately, a lot of testing required. We can't test simply like what we are doing in automotive sector, because automotive sector, anything, something happens to the car or some kind of bike or moped, whatever it may be, we can park aside of the road and we can check. But in the aerospace domain, it is not like that. So a lot of factor of safety required and a lot of critical testing methodology we need to follow to develop the compounds. So ultimately, this development of these kind of aerospace product right now, it is the hand of the mechanical engineers along with the aeronautical engineers. If you take any industry, aerospace industry, out of 100, 90 mechanical engineers will be there, and then 10 maybe other engineers including computer science, or it may be aeronautical, electrical, or some other branches. So our 90% mechanical engineers are capable to develop each and every component of this particular aerospace product. That's why when it comes to the development of these kind of aerospace, you can see this important chart. Here you can see the important charts. Here you can see middle composite product. This composite product is, you can think this one as a aerospace product, which you can we have seen in the previous slide. That is nothing but one F-16 aerospace product. So our aim is to develop this aerospace product. To develop this kind of aerospace product, ultimately you can see n number of different parameters here. Those who are in 8th semester, are those who enter just now into the 7th semester, are those who entered into the 3rd semester, and right now those who have taken admission for the 1st semester. You can see first semester students very difficult. Right now those who are in the 7th sem as well as those who are in the 5th sem, they might have seen all these terms. Materials, as we have studied in the material science subject, as well as the material testing, that particular lab, mechanics, kinematics of mechanics, theory of machines, and you might have linked with the strength of materials or mechanics of the materials, then design 1, design 2, or design of machine elements, and n number of analysis subjects. You can see analysis subjects. It may be answers, or it may be FEM, or it may be vibration, and meanwhile you are having the labs, tooling, whatever manufacturing process is going to cover this tooling, as well as the manufacturing, testing, all the things, inspection, repair, MBE. So these all are the important terms where we industry people are regularly using to make this product. That's why whatever subjects you are learning, whatever subjects you are studying, from simple engineering graphics to your 8th semester, any quality related subject, or it may be any other subject, each subject is having its own importance to make this end product which is capable to travel with a velocity of 2000 kilometers per hour continuously for 6 hours. So that's why you should not neglect any subject. So if you have to study not only for the purpose of mass, if you have to study for the purpose of nation's growth. So whatever you are studying right now, so those study only you are going to, that concept only you are going to approach to develop these kind of components. That's why if you see the materials, so you should know at least what is the density of each material. If I select to develop this kind of product, aluminum, what is going to happen? If I select to develop this kind of fighter aircraft, steel, what is going to happen? So you should be aware of that. At the initial stage, if you are going to use, or if you start to use a steel, what is the density of the steel? 7,800 kg per meter cube. When I am going to make entire aircraft or entire aerospace product with the help of steel, then what is the condition? What customer has given? Customer has given to supply this aircraft within the 10,000 kg. If you are going to use the steel, what is going to happen? It is going to reach minimum 30,000 kg. That basic concept you should be aware by studying important parameters, what you are studying by using material science and metallurgy subject. Same thing, mechanics of the material. So what are the different types of loads are acting at different zones, of which type of kinematics I need to use to operate landing gear of that particular aircraft. So what about the wing root fittings, and where we can attach the wing root fitting, and which type of root fittings we can choose for the best design. Everything is depending on whatever subject you are studying. So that's why each subject is going to have its importance. So each subject is going to have its importance to develop this kind of aerospace product. Means ultimately our mechanical engineers, those who are studying this subject, they are going to play a huge role to make this particular product. So those things only we are going to discuss in the coming slides. If you see this particular design, as you are aware of any compound design, if you take simple this pen design, ultimately this is based on the which type of material you are going to use or which type of design you are going to approach. If you see this pen tip or refill tip, when you are putting a particular pressure or when you are writing, 100% you are going to put some amount of pressure on that. So ultimately that pressure, whatever you are putting on the paper with the help of this tip should not deform. When this tip of this particular refill is deforming, ultimately you are unable to complete that particular process. Same thing, you should be aware that.
One ನಿಮಿಷ ಸರ್.
Yeah, sir. Yeah, sir.
Excuse me, sir. Recording on ಮಾಡಿ.
Sir, is it audible, sir? No issue, sir.
It's audible. You start the thing, sir.
Sorry, sir.
Recording. Can you record it? Recording on ಮಾಡಿ. Recording.
Yeah, sir. I am searching that option, sir.
You are the host. You can record, sir. Why you are asking him to record?
Recording in progress. I started. I made it, sir. I hope it will be recorded. Okay, sir.
Okay, no issue, sir. Go ahead, sir.
If you take this simple pen, so when you are putting pressure at the time of writing, the tip of this refill should not deform. Once it deforms, means ultimately you are unable to complete the writing process. So that means you should be aware which type of material I need to use and what is the maximum ultimate strength or what is the maximum yield strength. Always design takes place with respect to the yield strength only, because after yield, ultimately, as we know, this stress strain diagram. Stress strain diagram comes in your mechanics of materials. If you have thoroughly studied stress strain diagram, you will come to know what is the importance of design or what is the importance of that mechanics of materials. That's why this design is going to play a huge role. Always our mechanical engineers, if you go for any interview, whenever they are attending after completion of their engineering or it may be their campus time, so ultimately I come for the interview. Ultimately I am going to ask first question, do you aware of the stress diagram? Right. Then we are going to ask a lot of parameters with respect to stress strain diagram, because stress strain diagram is the basic diagram of a mechanical engineer. So he should be aware what is the elastic limit of each material, what is the proportional limit, what is the ultimate strength, what is the yield strength. So n number of parameters are there. If they are aware of at least which materials commonly we are using, like it may be steel or it may be aluminum, it may be polymer composites, or you can take it may be titanium, or it may be our household appliances, what we are using, mild steel or some other kind of germanium material or stainless steel material, whatever it may be. If our mechanical engineers are having these basic knowledge, they are going to become a good designer. This term you can see here, design with question mark. Why question mark? So n number of designs are there. If you see this kind of aerospace product development, which is new to the industry, at that time you can call it as a complete entire new design. If any modification with respect to the some product, this product is there right now, this product is unable to write for 1 kilometer. That means you are going to enhance something performance of this product. So at that time you may increase little bit diameter of that particular refill and you can fill little bit more amount of that ink. So you are capable to write 1.2 kilometers. For example, I am saying that kind of design we can call it as a we can call it as a redesign or modified design or whatever it may be. That's why to develop a aerospace product which is capable to travel 2000 kilometers per hour continuously for 6 hours, how our mechanical engineers has to approach this design. This is very important. Always I am going to say mechanical engineers have 3 important characteristics, 3 important parameters. That is, first one is they should have technically thorough knowledge. That we can call as a technical skills. In generally, as an industry person, I am going to call it as a technical skills of that particular mechanical engineer. Second one is innovative thinking. You might have seen innovative thinking. How I can approach or which is the best way to develop this kind of aerospace product which is going to weigh lesser than the 10,000 kg. How I can approach at the initial stages. So like that, they should have the innovative thinking. So once they have this innovative thinking mind, then technical skills, apart from one more important thing which is directly related to the product development, that is nothing but research mind. Innovative thinking, then they have the technical skills. When these two they are having, ultimately they have to apply their research mind. Once they apply the research mind, they are going to capable to develop these kind of aerospace product, or it may be this kind of automotive component. So ultimately, if you see this one, this is the one commercial aircraft. So this we are going to call it as a fuselage. This we can call it as a wing, and here entire thing we can call it as a empennage. This is the vertical tail, horizontal tail. Here engine is there. So ultimately, along with that inside, n number of components will be there, and here crews are going to sit. So your aim is to develop this kind of product. So when you want to develop this kind of product, ultimately you will start thinking how to approach design base, how to initiate this kind of project. Simple example I am going to take. Whenever you are having 30 by 40 site, if you are having 30 by 40 site, this is your site for example. So you want to construct house in this site. So what is your first step? Are you going to build an entire wall like this? It is not going to become house. It is going to become an auditorium, or it is going to become a seminar hall. So you have to have clear picture where you should have the hall, where you should have the dining hall, where should have kitchen, bedroom, and what about the other remaining parameters which is required. So all the things we have to represent with the help of some kind of diagram. That diagram generally we used to call it as a layout, or we can call it as a blueprint, as all of our mechanical engineers are knowing. Hence, so to initiate any construction of house or anything of construction, ultimately you are going to have blueprint. Like that, in the aerospace product, or it may be automotive sector, if you take this aerospace product, or if you take this automotive sector, anything, if you want to initiate your design phase, I'm not going to say like building, I'm not going to say direct manufacturing. So direct manufacturing takes minimum after 4 to 5 years, because aerospace domain is like that. So this is beginning of your project. How to initiate your project as per the customer requirement. You have to supply the aerospace product which is capable to travel 2000 kilometers per hour continuously for the 6 hours, and entire product should not be going to weigh more than the 10,000 kg. Keeping in this mind, with your innovative skills, with your technical skills, and by applying the research mind, you are going to draw what is the maximum length I can have to travel with a velocity of 2000 kilometers per hour. And meanwhile, the length should be in such a way that it should not be way more than 10,000 kg. So like that, you have to define important dimensions of that particular aerospace product. How you are going to give dimensions during your blueprint, during the construction of your house. Same thing, this is the initial step in the aerospace product, or it may be automotive product, to give the dimensions of that particular product. That means defining important dimensions of that aerospace product takes place at the initial stage. That is very, very important. How you are going to define these all dimensions? This is one more important question, because when you are constructing the house, you are going to define all these things with the help of blueprint. Your subject right now, CAD, computer aided engineering drawing. So this computer aided
Recording in progress.
aerospace domain, people are going to use to draw this kind of drawings. If you see here, we are going to call this one as a front view. Always, whenever we are seeing the aerospace product like this, we are call it as a front view, not this is the front view for us. This we can call it as a end view always. When we are seeing from nose to rear, we are going to call it as a end view. Here you can see the end view, and this is the, as we can see, entire top surface of that aerospace product, we can call it as a top view. Why representation of this view is very, very important at the initial stage? Why this three-view diagram finalization is very, very important in the aerospace product? This is one more important, because all the dimensions we can represent of that particular aerospace product, which is capable to travel with a velocity of 2000 kilometers per hour continuously for 6 hours with the help of this diagram. We can see overall length from here to here we can represent in the front view. Same thing, we can see the wingspan from here to here we can represent in the particular top view. And meanwhile, we can see at which track, what is the maximum track, or we can call it as what is the maximum runway required for this kind of aerospace product. This we can call it as a track length from landing gear LH to the landing gear RH. And meanwhile, here one more important parameter is the distance between the nose landing gear to the main landing gear. As an aerospace product term, we can call it as a base length. So all these things are very, very important to initiate any aerospace product, or it may be automotive sector. Here you can see this particular car also. What is the distance between front wheel to the rear wheel? Whether whatever people are sitting here within these two wheels, because maximum load will be within this range only. So when people are sitting this one and length is more, and whatever stiffness are not that much, chest is not that much strength carrying member, ultimately it is going to bend. What about the reactions? What is the maximum center of gravity for this particular automotive sector vehicle it is coming? Whether moments are sufficient, whether we have to stable the chest, everything we can study during the initial study. That's why this review diagram is very, very important diagram to initiate any aerospace product or to initiate any automotive sector product, because all the dimensions we can arrive at this stage, because this dimensions arriving is not depending on the single person. This is depending on the n number of mechanical engineers, with those who are working in different groups, along with them with the help of aeronautical engineers also. Whenever you are giving or defining this, for example, I am going to take this wingspan. This is the wing. You can see this wingspan may be 10 meter here to here, from this end to this end. Wingspan may be 10 meter. And if you calculate, just see my cursor. If you calculate this area, whatever this area is there, this area may be around 25 meters square. When you make this diagram, and when you are presenting this particular diagram to the groups or other design groups, ultimately they will see, what about the wing area of this particular aerospace product? 25 meters square. Whether 25 meters square is capable to lift this 10,000 kg aerospace product? No. They are going to say ultimately, no, it is not going to lift, because wing is the lead generation member for that particular aerospace product. When it is not capable to lift 10,000 kg, then what is the use of taking this aerospace product? So they may suggest, no, you give another some 5 meters square area extra. If total area is around 30 meters square, it will be helpful to me. So like that iterative or iterations are going to take place during development of these kind of activities. So finally, with all this, they may conclude with this is 10 meter, and this may be another 10 meter, and this width may be 1 meter from here to here, and this track length may be 3 meter, or this base length may be 2.5 meter, and overall height may be around 3.5 meter. Like that, they will give all the important terms. And generally, they will calculate how much amount of mass required to develop this kind of wing. Maybe 500 kg wing department will take 500 kg and you develop the wing. And another one more component of this aerospace product, fuselage. Fuselage department will take 10,000, 1,000 kg and you define. So like that, all weight distributions as well as all the dimensions takes place initially. This is not only in the aerospace product. This same is applicable for the any automotive sector, or it may be plastic domain, critical compounds, or whatever. So whenever you are going to draw this kind of diagram, whether is it sufficient to make any aerospace product, this 2D diagram, you can call it this is 2D diagram. This is line diagram, simple line diagram. So whenever you are seeing this particular Cairns box, when you are seeing from the front, so you can see only this area, either rectangle or it may be triangle or whatever it may be. When you are seeing from the front, you can see this rectangle. sorry, this triangle. When you are seeing from the front, you can see only this rectangle. So whether this rectangular triangle are sufficient to store this kind of crayons within the this box? So it is not possible to store this kind of crayons within this box. You should have the volume. That means whenever you want to fabricate, you want to produce any kind of component, you should have volume. Then only you can start filling a number of compounds which are capable to make this particular aerospace product as a flying agent. Then only it is going to fly. If otherwise you have to make paper aerospace product and you have to hand over to the customer, it is not going to fulfill his requirement. So conversion of this particular 2D diagram to a 3D model like this is the important stage of any aerospace design or aerospace product development stage, or it may be automotive sector development stage, because this will give you clear picture. So what is the volume of this particular aerospace product, and what about this surface, outer surface, how it is going to look. This outer surface is capable to travel with a velocity of 2000 kilometers per hour or not, that is going to say. This outer geometry usually in the aerospace product or it may be in the automotive sector, generally they are going to know this, you can call it as an outer geometry. If you take water bottle, simple example of this kind of box, how it is looking right now, this is looking something different. Is it capable to travel 2000 kilometers per hour? No, this kind of shape is not suitable because it is going to have a lot of drag. So how to improve the drag or how to overcome that particular drag? So everything, that kind of activity will take place during this conversion of 2D diagram to the 3D model. This 3D model, once they make outer geometry, only outer geometry, they are not going to see in this particular step what you are going to fill inside. They are not going to bother. Right now that outer geometry, whatever outer shape is there, that outer shape is capable to travel with a velocity of 2000 kilometers or not. That we need to check. So that's why this numerical geometry, this numerical master geometry, ultimately aerospace down or aerospace people or automotive people, they are going to call this outer geometry of any object in the industry, they are going to call it as a numerical master geometry. This is very, very important, and this is the one-time activity. Whatever you are seeing a number of different aircrafts or different helicopters in the air right now, or in the TV you might have seen, or in the some kind of shows you might have seen, those things maybe developed 15 years or 20 years back, whatever this kind of say, one-time activity. After filling a number of components within that, they made it as a flying agent. So this is the one-time activity. Why I am going to say this is the one-time activity and we have to take more concern means, if you are decided from this end to this end, overall width of this particular aerospace product 1 meter, after 10 years you are going to change 1.2 meter, means that is going to become once again new project. Whatever till now you have put effort, that is going to destroy, that is going to failure. That's why this is the one-time activity. Whatever shape you are giving, that shape, if I am developing this particular outer geometry in the year 2021, so if you are going to fly this aerospace product in the year 2030, this outer geometry remains same. It looks like same only. Maybe you might have changed different types of components inside. That's why validation of this particular outer boundary is very, very important, where our mechanical engineers are going to create this outer boundary with the help of n number of CAD tools. As we are aware of, n number of CAD tools like CATIA, or it may be you may knowing Unigraphics or SolidWorks, SolidEdge, whatever it may be. So here, how to prove this one? Because this whatever air is passing here, when it is traveling with a velocity of 2000 kilometers per hour, here should not be any dents, or here whatever surface is there, this surface should not create any turbulent air flow. It should be uniform. It should be traveling like this. Simply, it should not disturb more to the efficiency of that particular aerospace product. For this reason, usually our mechanical engineers along with the aeronautical engineers, they are going to evaluate this particular model by using we can call it as a CFD analysis, as well as we can call it as a wind tunnel testing. Wind tunnel testing is nothing but they are going to make this particular testing by making one scale model. That means if we have at the initial stage assumed this one as around 10 meters, so ultimately you are going to make 1 meter scale model. That model you are going to place that model.
ಸರ್ ಒಂದ್ ನಿಮಿಷ ಸ್ವಲ್ಪ ಅಟೆಂಡೆನ್ಸ್ ಒಂದು ಡೌನ್ಲೋಡ್ ಮಾಡಿ ಇಟ್ಕೊಳ್ಳಿ, ಆಮೇಲೆ ಕಳಿಸಿ.
Sir, where we can get it?
ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಅಲ್ಲಿ ಇಲ್ವಾ?
ಅವರು
participant list is there, sir.
Sadanand, we can have attendance, no problem, sir. Later it will be in the Zoom. Whoever came, no, it will be in the Zoom. It will be there. Are you sure, sir?
You can take
sure.
screenshot, sir.
You please take few photographs, good photographs. That is enough for the program.
Yes, that is
Photographs I have taken. Okay, sir. Okay, sir. Sir, sorry for the interruption. Thank you. Take some random
like
time snaps.
that particular wind tunnel model, they are going to make scale model. If this is the aircraft with 10 meters, then ultimately they are going to make one aerospace product with 1 meter. That is nothing but 1:10 scale. They are going to place this model in a wind tunnel. As the name itself suggests, tunnel. Tunnel is nothing but we can call it as suranga. In either it may be Telugu term or it may be Kannada term, remains same only. And winders tunnel, they are going to pass artificial air, which is traveling with a velocity of 2000 kilometers per hour. And they are going to mount this one with the help of a number of sensors. And ultimately, that is going to absorb how this particular body is disturbing when it is traveling with a velocity of 2000 kilometers per hour. Whether this kind of surface is capable to, but this is very important. When it is traveling in the air, when we are going to hand over to the customer, when customer is flying in the air, or during testing, when we are testing after completion of all the production, when we are testing, at that time we should not tell no, this particular aircraft is not capable to travel 2000 kilometers per hour. It may go only to 1200 kilometers per hour. Whether that customer is going to accept this kind of product, ultimately no, because he has mentioned in his customer order clearly it should capable to travel 2000 kilometers per hour. That's why you have to do with the help of n number of CAD tools, n number of simulation products, or n number of different softwares. You have to prove that whatever product we have made, this outer shape is capable to travel 2000 kilometers per hour. Everything you have to decide at the initial design phase. Once this is decided, outer surface is proven by the wind tunnel, proven by the CFD analysis. There is no any much difference between these two, conventional method as well as the software method. Then next step is to fill inside whatever required to make it as a flying agent. When we are having this kind of mobile, only outer surface we are having. We don't have any motherboard inside or any kind of electronic devices. So whether it is capable to speak? No. Same thing. Whenever we are having this kind of outer boundary or outer geometry, our aim is to fill n number of components inside. You have to fill seat, you have to fill oxygen, you have to fill n number of electronic components, you have to fill antennas, and you have to fit the engine, and n number of different navigation system related equipments you have to fill inside the product. Then that is very, very important, where we are going to keep all this systematic arrangement of component within this volume, that we can call it as the internal structure of the aerospace product. All activities takes place from conceptual design to the detailed design. So whatever right now we have seen up to right now, 3 view, that is the concept you are having. That concept you are going to convert into the detailed design. How you are going to convert detailed design? That means by the technical skills, by the innovative thinking, what you are having, you will come to know. So I have given dimensions for particular aircraft this much, 10 meters. Wingspan I have given 11 meter, and area I have given 30 meters. This kind of dimension is capable to make this one as a flying agent. You will start thinking. Then conversion of this all whatever dimensions are there into real picture takes place in this way. So it is not sufficient. Once again, you have to fill n number of components. So after filling n number of components in a digital way, I am telling. Initially, all these activities takes place in the aerospace industry, or it may be automotive industry, in a computer level or in a system level. Once you will have that confidence, then detailed design will take place. Detailed design is nothing but you are going to start fabricating each type of these components. That means to make this outer boundary of this particular aerospace product, so you are going to develop here one structure and the structure, so many ribs will come, so many parts will come, like a skeleton of our human body, and how our human body has developed, so a number of ribs are there, and how in between the connecting members are there. So like that, this aerospace product we need to make, and we are having top skin, like that you have to make skin with the help of some kind of sheet metal work, like that 10 number of components. To complete this entire product, you have to develop more than 1 lakh different parts, where our design engineers are going to play a huge role. So you have to adopt which type of design you have to make one simple compound. Which mechanism is involved to make the landing gear? Which mechanical is involved to fit this particular wing to attach to the fuselage? Whether it acts as a cantilever beam, when it is acting as a cantilever beam, what about the bending moment? What about the shear force? Like everything you need to think. Simply design means you should not go and fit it here. No, not like that. You have to evaluate everything and you have to do the calculations. With the help of that calculations, you have to make it in a systematic design. So along with that, you have to choose to make any component proper material selection. That is very, very important. If you see this next slide, selection of materials, because your duty is to make or your duty is to develop around more than 1 lakh different parts. All the parts you are going to assemble with the help of some kind of sub-assemblies and major assemblies, and entire product you are going to build ultimately at the later stage. Whenever you are making at the part level, when I am going to take this particular crayons, so this particular crayon, when I am going to start trading, it is simply breaking means what is the use? So like that, and when you are going to put into this all crayons into this box, then end use is end application is not going to fulfill. So that's why, so at the part level itself, you have to make in such a way that at the part level itself, you have to design in such a way that this particular part should not fail. When part is not failing, then you need to check assembly also. Assembly should not fail, and major assembly. Entire, you have to think about the as an entire aerospace product also you need to be developed. So like that, at the part level, you should select suitable material. That material should have the mechanical stability. Mechanical stability, as we know, as I explained in the previous example, when we are writing pen, that should have particular amount of resistance to deform. And what about the strength? What about the stiffness? Everything you should know at least for the basic material, and electrical and thermal conductivity. Simple example, when you are going to make one particular part, this kind of part, which is coming inside the engine, at that time, if you are selecting material as a plastic, whether it is going to fulfill your requirement? No. Engine temperature will be very high, maybe around 900 degrees Celsius to the around 1000 degrees Celsius. When you are using plastic compound, it is going to burn. When you are using aluminum particular material, it is going to waste. So like that, you should have at least basic ideas about the materials, because entire 1 lakh components is in the hand of mechanical engineers. Along with the design knowledge, along with the mechanics of materials knowledge, along with the kinematics of machines knowledge, along with manufacturing technology, you should be aware of material science also. Then only you can become a good engineer, and whatever part you are developing, that part is not going to reject by at later stage by some other quality people or some other inspecting agencies. If you are using instead of titanium, aluminum for the engine at hot zone, ultimately they are going to reject. Hey, how you are designed, man? Your design is not good. Go, you have to change the material and send the redesign once again, because industry means this particular part, when it is going to fabrication, means it is not simply I am designing, I am going to fabricate, not like that. To design of simple steel, lot of inspection agencies will be there, and lot of approval departments will be there. They have to approve. They are going to check each and everything. It is not just like a automotive domain. So simply that one steel has come down, I will take that steel with help of some other steel. Not like that. So each and every part of that particular aerospace product has to release through some kind of design quality or design related groups. Then only it is capable to manufacture, and ultimately it is going to be on the aircraft. So like the different terms are there. I am not going to say all the terms here. Like that, I have given some few examples. So ultimately, why these people are much more. If you see that initial slide, what I have explained, that particular aircraft should be capable to travel 2000 kilometers per hour continuously for 6 hours, and weight should not be more than 10,000 kg. So why these people are bothering about the mass? But let it go there more than 10,000 kg. What is going to happen? Why these people are restricting about the weight? Because if you see here, so this 45% in this particular pie diagram, 45% of his cost, whose cost? That customer cost, who is going to take your aerospace product, either it may be Indian Aerospace, Indian Army, or it may be some other agencies. Those who are going to take, they are going to pay more than 45% of their cost for filling fuel. So 1 kg rise in the weight of that particular aerospace product, ultimately that is going to consume 1 liter of petrol extra. How we we are going to define life of that particular aerospace product? Always we are going to define life of that aerospace product in terms of flying hours. That is the 10,000 flying hours, or it may be 30 years. That means whatever aerospace product we are handovering to the customer, it should be capable to travel minimum 30 years or 10,000 flying hours, which is reaching first. At that time, they are going to ground the aerospace product. For 30 years, when you are going to fly that particular aerospace product, what about 1 liter rise in the 1 kg rise in the mass? He is going to consume 1 liter. Like that, he is going to put more than 1 crore liter of that gasoline. So ultimately, he is going to pay more than crores together amount for this fuel charges only. That's why he is always going to bother about the weight, because efficiency is directly related to the weight. If you come here, so how to define or how we can fabricate? As you were aware of that material science, that particular subject, always we are thinking about the less density material and high strength material. When you are reducing the density with respect to this slide, your strength, fatigue, and other parameters should not come down. When you are choosing instead of aluminum, I am going to take polymer based composite. When you are going to take polymer based composite, what about the density? Density is 1400 kg per meter square. Then what about the strength? If strength is not fulfilling, what is the use? Although you have made aircraft with the polymer composite, when it's going to be traveling in the air, it is ultimately going to fail. What is the use? Ultimately, that is no use. So like that, you choose material in such a way that density should come down and strength should be more. In generally, what we are going to call as the strength to weight ratio should be very high. That's why you should not, what I mean to say here is, you should not neglect that material science subject also, or theory subject. Whatever subject you are learning from the first semester to the last semester, you should have same importance. You should give same importance to all the subjects. Here see a number of materials are there. I am not going to take that much time on material related. I am going to highlight what is the importance of materials along with this one. Here if you see aluminum alloys, what we are using for the aerospace materials, aluminum alloys more. And next a number of different composites are there. Right now entire aerospace product development is mainly based on the composite materials. Composite materials is nothing but, as we know, the polymer based composite. We can see this particular Boeing 787 aircraft. In this whatever blue picture you are seeing here, this particular blue is made up of composites. Right now, in the commercial aircraft, or it may be in the automotive sector, or it may be aerospace sector, people started using this polymer based advanced composite materials more. And one more important term I am going to highlight here to our young mechanical students, that is, one important thing is, whatever polymer composites we are developing in our country, that is not suitable for the aerospace applications. We can use that one for the automotive sector applications. Still indigenous. Any doubt, sir?
No issues. Hey, who is that? Hello?
Still indigenously, still now, we are not developed any composite for the aerospace applications. That's why it's our young engineers' role is to have research mind to develop these kind of composites for the aerospace applications. So if you see here how trend has started, so right now in the year 1980, only less in the year 2005 now onwards, so we started using advanced composite materials more than 50%. It has to increase still more to have the lightweight body. Why I am going to highlight this one is, this is the hot area where our faculty members as well as our young researchers need to have concentrate on the development of the polymer based composites for the aerospace applications, to make them as a end use, not for the research purpose or not for the publications purpose. Ultimately, goal should be to bring into as a end product. That is very, very important. That's why I am highlighting here. So ultimately, when you have the thorough idea, you have the conceptual design, you have the detailed design, and you have done all the CAD models of 1 lakh products, and everything is there. Now you started developing compounds by using CNC machines or by using some kind of lathe machines, or it may be some kind of other equipments. Then everything you have made parts also, everything is ready, and you have made the assembly also. Then how we have to prove whatever parts we have developed and whatever assemblies we have made, whether these assemblies are suitable to use on the aircraft directly or the aerospace product. So what is the important? Important is the testing. So whatever you are studying in your material science, and materials is a subject that testing, materials testing lab, design lab, your ANSYS lab, what we can call it as a comma lab generally, and some kind of heat transfer labs, and n number of other labs will be there. All labs are going to play a huge role. As an industry person, maybe we are using as per high standards, but whatever basic concept we are following in any industry, those basic concepts are directly we are gaining from the academic subjects only. That means academics lab, what you are studying, those labs are very, very helpful, because procedure and other methods are remain same only. Maybe standards are some kind of Bureau of Indian Standards or American Society of Testing Material Standards maybe remains different, but whatever basic concepts are there, those concepts are very, very important, and whatever you are studying, those things only we are going to use in the industry. For simple example is to arrive ultimate strength of any material or hardness of any material, we are going to use universal testing machine, what you are going to use in your lab, and we are using same thing in our industries also. Whatever mineral hardness to test the hardness, we are using same, maybe because we are using, and sometimes rockwell also based on which type of material we are using, same thing. That's why this testing plays very, very important role. In this particular another 10 to 15 minutes talk, I am going to wind up. I am going to cover how this testing is very, very important to make any aerospace product, or it may be automotive product. If you see here, in number of different testing will be there: static stress, or it may be dynamic stress, or fatigue testing. So almost all whatever components we are seeing, either it may be aircraft or it may be helicopter. So after certain years or after certain years, it is going to fail. Why it is going to fail? Due to these reasons. You can see in this particular slide, these are the reasons to make any particular product to fail. So that is static load stress. Simple example for the static load stress is nothing but one particular, here one tray is there. On that tray I am going to place battery of that particular aerospace product, which is weighing around 50 kg. So when I am mounting this particular battery like this on this particular tray is nothing but we can call it as a one bracket you can assume. So which is made up of aluminum. So I am going to keep this bracket for a period of around 30 years, because life of this aerospace product is up to 30 years. Whether this bracket is going to remain same, some kind of static load stress will be there. That means, so maybe it may be due to the surface to surface contact between the product, that battery, and this particular bracket, and maybe due to some chemical interactions between the base material with respect to that particular battery. So like that, which type of material I have to choose for this particular bracket, and what about the thickness of this particular bracket, whether it is capable to take this 50 kg over a period of 30 years or not. Your thing you need to decide at the type of at the beginning time only, when you have added or when you have mounted the battery, and that is a particular aerospace product is flying, then afterwards some disturbance is there due to the vibrations or due to the fatigue life and other things, I am going to change, then it is time consuming. That means your design is not appropriate, your design is not good. So like that, at part level design only our mechanical engineers has to think. Who has to take here blame? Here blame has to take by our Royal Mechanical Engineers only. That's why if they are having thorough knowledge about the different types of loading conditions, different types of strengths, different types of mechanics, and different materials, with all these combinations, if they have developed that particular tray or particular bracket, then they can mount that battery over a period of 30 years, say no issue in that. So like that, different loading conditions, different testing methods we need to follow to prove particular product. Either it may be analysis result, or it may be conventional testing results like tensile test, hardness, or it may be fatigue test, whatever it may be. So I'm going to cover in this particularly fatigue, because if you see any aerospace component like this is the fuselage. We can call it as a center part. You can see this image by seeing this one. This is just like our body. Whatever you are seeing here, just like how we are looking right now. When you are scanning, then your body looks like this. Whatever ribs, pass, like that, your skeleton is seeing. Same thing when you see the aerospace product like this. So we don't know what is going to happen when we fall from something, when we are playing or whatever it may be. So some injury may be happen. That injury, how you are going to check? By using scanning or by using x-rays or whatever it may be. Same thing. So whatever some kind of cracks in initiated within the body of this particular aerospace product, how to judge that one, because this cover is there, inside something happened, we will not come to know. When will not come to know, ultimately what will happen? Here same thing, here one window is there, here another window is there, some kind of crack initiated here, and it has touched to the other window, finally it has led to the a crash like this. It should not happen in the real time. When it should not happen in the real time like this, so ultimately what is the role of our mechanical engineers? Our mechanical engineers role is they should not develop ultimately from that particular part to the ultimately from the overall assemblies, full assemblies, they should have thorough testing. That's why this testing is very, very important. As how we are doing design, how we are doing manufacturing, after that to prove that material whether suitable to use in this particular aerospace product or not, testing is very, very important. That's why if you see n number of components, mainly failure due to the fatigue life, because almost all in the aerospace domain, whatever crashes you are seeing or whatever some kind of aircraft crash or some kind of aircraft failure we are seeing right now all over the world, mainly due to the fatigue life. Because fatigue is very, very important, where we can see the repeatedly applied load which can cause the crack very easily. That's why those kind of components our mechanical engineers should be much aware, and they should know which kind of components out of 1 lakh are the critical and non-critical. Everything you have to judge if that is the critical, and how factor of safety you need to apply, how design you need to initiate, which type of material I have to choose for 30 years. Everything you should be aware. That is very, very important. So if you see here, always fatigue life design, how industry people are going to take safe life as well as the fail safe. Safe life means, so up to 30 years or 10,000 flying hours, that particular aerospace product should not fail. That means if you take the landing gear of any aircraft, if this is the landing gear, it is going to land more than around 10,000 times during a period of around 30 years, for example. If it is going to break when it is going to land at 100 times, so it is going to fulfill, your entire aerospace is going to collapse. This should not happen. For the customer point of view, he is not going to accept all those things. That's why you should think, so if I am going to land 1,000 times, so ultimately which type of material I have to choose, what about the dimensions, what about the robust design or factor of safety I need to follow, everything you need to think. If this is like a body or skin, so at that time fail safe, some kind of crack it is occurred on the surface, that crack you can patch with the help of some kind of instruments or some kind of patches or whatever it means, that we can call it as a fail safe. Why I am going to highlight this one is our mechanical engineer should be aware of that while designing any component, either it may be small mobile or it may be small pen or it may be automotive sector, or you can take any water bottle. You should know where exactly which type of load is coming, so which type of material we need to choose, which type of analysis I need to do. If I am going to take the thickness, if I am sitting on this chair, so if I am going to choose thickness of this chair as a 1 mm only, whether it is capable to take 70 kg on this chair or not, everything you should be aware. So all those things are very, very important, where our mechanical engineers should be aware at the initial stage. Then only you can hand over the successful product to the customer. If you see here, any aerospace product, when it is traveling on the ground means that is on the runway, it is traveling with a velocity of 400 kilometers per hour. Now your aim, when it is coming on the air, here it is coming in the air, so ultimately what is your aim? It should capable to travel 2000 kilometers per hour. When it is landing, once again 400 kilometers per hour. Here with different types of loads we can see on the surface, sometimes heavy load, sometimes lesser load, so like that fluctuating load is hitting on the surface of the aerospace product. At that time should not fail. It should not fail means you should have the thorough testing. So like that, whenever you have developed this kind of products like aerospace product at part level, you can see simple part. If you take a best example of this particular pen, you have developed this tip of this particular pen, and when you are assembling this tip to this one, so as an individual, when it is coming, so spring is hitting inside. When the spring is hitting inside to this portion, ultimately it should not fail. That you need to check. When it is hitting and when it is failing, when you have assembled everything full and when you start writing at that time failing, means whatever design entire thing you have made, you have redesign. So that is time consuming. It should not happen. So that's why as alone you need to do, that means at a part level, and when you have clubbed this tip of the pen with this black portion, so at that time Also you need to check as a sub-assembly level, and when you have added this and this one as a major assembly or main assembly we can call, at that time also testing required based on the where exact we are using and where exact this particular compound is coming or part is coming. This type of different loads are acting on this part. Everything you should be aware, and you should be analyze those kind of loads and those kind of critical parameters. Then it will be a successful product. So like that, if you see here, this is the wing of that particular aerospace product. If you see, this is the wing. That in the real time aerospace industry, people are going to check for the product, for the what we can call it as a prototype vehicle. That means before free production, prototype vehicle will be there. They are going to check this wing alone. When they are going to check this wing, so ultimately they will apply to lift this 10,000 kg. How much weight is coming on this particular wing? Whether this particular wing is capable to take 10,000 kg or not. So if it is 10,000 kg, it has to lift. That means minimum one side it is going to distribute 5,000 kg. Whether this kind of surface is going to take 5,000 kg or not, it is going to should not collapse. Then how to do that one? If that is collapsing as a single wing, no issue. When it is collapsing as an entire product, that is useless. So let it go one particular wing, let it allow to destroy and prove it whether this particular load is taking or not. So entire aircraft level, before flying any product, the entire aircraft level testing is going to take place. This is landing gear where you can see same thing what I have explained earlier. So this entire aerospace product, here you can see this as a whole entire product which we have developed, which we have designed, which we have developed, which we have manufactured at part level, and part level testing has been done with respect to the critical compound wherever required, and ultimately those assembly happened, then the entire aircraft is ready like this. Ultimately we have to think before flying or before taking first flight, so whether this kind of aerospace product is traveling in air with a velocity of 2000 kilometers per hour, it is going to sustain or not. Like that, they are going to check with the help of the loads. Here you can see here dead loads, and these loads are attached with strain gauges, sensors, and data it is going to retrieve. When it is traveling with a velocity of 2000 kilometers per hour, our wing should not detach. So like that testing will be there, because all these testings will be done by our Royal Mechanical Engineers only. So hence from initial stage, from the customer order to the end product, like this kind of product. So ultimately our Royal Mechanical Engineers are going to play huge role by using either it may be elements of mechanical engineering subject, drawing subject, or it may be FEM analysis subject, or you can see the manufacturing design, mechanics of materials, kinematics, all the subject we are going to use to make this kind of aerospace product. So once testing is over, everything is done, then ultimately, so a lot of procedures will be available to make this kind of aerospace product. So those procedures, what they defined during developing the prototype vehicles, ultimately they are going to follow that one for the series production. Ultimately they will do the series production, and finally they are going to hand over this kind of aerospace product to the customer. So like that, in each stage, it is important to have our mechanical engineers role. That's why always we are going to call our mechanical engineering students as a Royal Mechanical Engineering students. Not only this one, whatever cycles are involved from end to end to develop this kind of products, whenever some kind of software requirement is there, our mechanical engineers can learn the software like Java, or it may be SAP, or it may be some kind of programming language, C++, or whatever it may be. They can become software engineers, but never a software engineer can become the mechanical engineer, because they are not going to operate on the lathe, they are not going to have the program for the CNCs, or they don't know how to design subject, design equations, whatever bending moment equations you are having, whatever Euler's formula you are having, whatever deflection equations you are having, those things very difficult for them to calculate the bending moments or shear force diagrams. So hence always a mechanical engineer can learn software subjects or softwares, and he can become a software engineer, but a software engineer cannot become a mechanical engineer. That's why always we should be proud to be a mechanical engineer. I am going to end my session here. So if any doubts, any clarification required, you can ask me any questions also. Is it okay, sir? Sachidan sir? Sadan sir?
Yes, sir. Yes, sir. It is okay, sir. Absolutely fine. Very nice presentation.
Because I required actually 2.5 hours for this station, sir. As you said, 1 hour maximum. That's why I wind up in little bit faster manner. We can have one-to-one interaction with the students in live sessions, sir. If possible, one time I will come to this Vidyaniketan College of Engineering there, and we can have interaction with them there. It will be more better to discuss with the Royal Mechanical Engineers, sir, in future if possible.
Yeah, that would be definitely see that is a good idea, sir. We will see some other time, maybe very soon.
Yeah, yes.
I think because of this online session is not much convenient, especially the
Correct,
subjects
sir.
like
I also
this,
don't know, sir,
aerospace,
whether whatever I am
which is
speaking
very
and the
critical.
students are listening or not, and what they are doing is very difficult. If one-to-one interaction is there, I can drag this session up to 3 hours. It will be good for the students, and we can draw some kind of shear post diagrams and everything, how we are utilizing our mechanical subject in real time. That we can explain, and that students can feel we are learning very good subject like this.
Yeah. You can just bring in some taste of flight without formulae. I think
Yes,
you can
yes.
give good exposure so that it can be encouraged. Yes, sir.
Sadanand sir,